Okay, hi everyone. My name is Anton Evangelatov, and I'm an engineer at Protocol Labs. I hope you have a fun time watching the presentation so far. They've been great. Yeah, if you've missed them, yeah, make sure that you check them on YouTube after the dev talks is over. So today I'm going to talk to you about Testground and how we used it to test Lotus implementation of Filecoin prior to mainnet. So first of all, what is Testground? So Testground is a platform for testing and benchmarking and simulating distributed peer-to-peer systems. It's designed to be multilingual and scale gracefully. And in the past, we've used it to test various protocols and systems, such as IPFS, GossipSup, and others. Testground is a relatively new project. It was incubated in Protocol Labs last year in 2019, and we've had our public launch earlier this year in May. It is open source, and you can find the source code on GitHub, so feel free to use it for your projects and contribute back to Testground. So let's have a quick look at the features that Testground delivers today. It supports network traffic shaping, so you can adjust network latency, jitter, and other parameters to simulate real-world network behaviors. It supports multiple builders and runners. What does that mean? Basically, you can build tests with, for example, the Go programming language, and JavaScript is in the works. And you can run them locally as processes on the host system as Docker containers, or you can run your test plans remotely on a Kubernetes cluster. At the moment, there is work undergoing to support other languages. Testground has a distributed coordination API backed by Redis, which provides easy-to-use synchronization primitives, such as barriers and locks, and allows for very easy coordination between multiple test plan instances. Testground also supports complex test manifests. We call them compositions. They allow you to run a test composed of different versions of your code. For example, building a network with various versions based on various dependencies. So for example, you can run a test plan which exercises a given library version and the new version of the library, and make sure that the different versions work nicely together and you're not introducing any backward incompatible changes. Let's go over some of the core Testground concepts so that you understand the later part of this talk and how we actually used Testground to test Lotus. Testground has a notion of test plans, as I mentioned. So these are the tests that you implement and you run on the Testground platform. And they can have from 2 up to 10,000 instances. So a test plan could, for example, describe a Falcon network, which consists of n miners and m clients that want to store data on the miners in your test network. Builders are the functionality which is responsible for producing an artifact for your test plan that will later be run with a specific runner. Currently, we support mostly the Go programming language with support for JavaScript coming soon. Runners define where your test plan will be run on your local machine for fast iteration and feedback loop, or remotely on a Kubernetes cluster if you have requirements for more resources or instances than your local machine can accommodate. You are free to implement any other runners that you find necessary, even if we don't support them. So you're not locked only with, let's say, Docker and Kubernetes. Test plan instances coordinate with each other through the synchronization service that I mentioned earlier. So this allows you to write one program, or as we call it, test plan, that is run n times with n instances. For the engineers among you, if you've participated in distributed code jam competition from Google, Testground synchronization works similarly. So basically, the same program is run multiple times, and depending on a sequence number that your individual instance gets, or depending on the group it receives from the run environment, it can execute different code, but ultimately you are writing one and the same program, which makes it very easy to develop. Testground has an observability pipeline, which allows Testland to emit outputs and metrics for analysis after the test run is complete. And I'm going to show you an example of that later. And last but not least, the sidecar is an individual Testground process that's responsible for network management and traffic shaping for Testland instances. It runs in privileged mode on the host machine and listens for requests from Testland instances for network configuration through the sync service. So Testland instances can request specific network configuration from the sidecar, and it can amend the network options for them, be it latency or bandwidth or anything else. So here is a diagram that visualizes how those concepts fit within Testground. You can see that every test instance receives the so-called run environment, which contains run information, Testland information about Testland being run. Every instance emits events or diagnostics or results. The diagnostics and the events are also stored in InfluxDB, whereas currently the results are stored on Amazon EFS when you run with the Kubernetes runner. The events and the diagnostics can be visualized with Grafana because we have it configured to point to the Testground InfluxDB instance. And you can immediately, while the test plan is running, visualize them on a dashboard and get insight into your test plan. Another way to examine the outputs of a test plan is to load them in a Jupyter notebook environment and produce visualizations and insights with this powerful toolset that many data scientists are familiar with. This is the approach that the Gossip Sub team took, and it worked very well for them. There is a presentation later today on Gossip Sub, so you might want to tune into that and listen to the work that the team did. All of this is documented on our documentation website at docs.testground.ai. So check it out to learn how to write test plans and how to run them locally or in a cluster, how to use the infrastructure playbooks, and everything else related to Testground. So how does all of this fit with Falcon and Lotus? How did we use Testground to test Lotus? Enter Project Oni. Project Oni was incubated in June 2020 with the mandate to verify the successful outcome of the Falcon protocol under a variety of scenarios. The code base is open on GitHub, so you can have a look exactly what it entailed. The work that we did as part of the project can roughly be split in 3 different areas. So test plans that are exercising Lotus on Testground, interoperable VM conformance test vectors. So these are extremely important and are already adopted by multiple Falcon implementations, such as Lotus and the chain-safe forest implementation. Ru had a full talk on that earlier today, so make sure that you watch it in case you missed it. And state diff, the tool that compares the state trees. Will is the main person behind state diff and has a presentation later today, so definitely check that out as well to learn how to inspect various state differences in the state tree produced by Filecoin. I'm going to talk about the test plans we wrote for Testground that exercised Lotus, which is the first part from this slide. So as part of this effort, we implemented TestKit library in Go, which helps anyone to easily write test plans that exercise Lotus in a variety of ways. So in Project Oni, we wanted to test Lotus programmatically, meaning import the Lotus libraries in our test plans so that we have more control over the internal APIs and configure Falcon networks in a way that's not really possible if you run vanilla Lotus nodes or storage miner binaries. While this certainly worked well for us, the downside is that these tests are completely tailored to Lotus and they're not interoperable in nature, unlike the VM conformance tests. So if you want to reproduce those results with, let's say, a different Filecoin implementation, you would have to amend the tests. If it's a Go implementation, it would be easier. If it's a different language implementation, you would have to rewrite some of it. So with this test kit, you can easily bootstrap networks with various numbers of miners, clients, amend their configuration, such as block delays or message confirmations, or number of epochs for deadlines and other network-specific parameters. You can also attach a custom DRAND network to the Filecoin network that you're starting. So the test plans that we implemented cover a number of topics. Slashing conditions is one of them. We recreated scenarios that lead to slashing. So for example, window proof of space-time misses and sector proving faults. On Filecoin, every miner should prove that they are storing sectors they have sealed, and those sectors give them power in the network. And they should submit proofs on chain within their respective deadline periodically on a daily basis. When a storage miner fails to complete this window proof of space-time for a given sector, the Filecoin network registers a fault for that sector and the miner is slashed. So we triggered scenarios that exercise this behavior and verified that fees for the so-called temporary faults and sector termination are enforced. We ran a number of end-to-end storage and retrieval deals with a variety of configs, including stress testing the network. We ran payment channel stress tests. So unlike storage deals, on Filecoin, retrieval deals are fulfilled off-chain using payment channels to incrementally pay for data received. So payment channels were exercised in their own tests, but they were also exercised in the deals end-to-end test as well. And last but not least, we triggered various DRAND incidents. So we stopped the DRAND network attached to our test Filecoin network. Obviously not the production one because we don't control it, and you wouldn't want to do that with the production network. And then we examined the effect that has on the Filecoin network. So during the test runs, we used all the available tools from Lotus, such as this nice Grafana dashboard that comes from the Filecoin team. And we can visualize different parameters of our test networks. For example, you can see on this dashboard that we're using a block delay of 2 seconds instead of 30 seconds. And the reason for that is that we don't want to wait for hours to perform simple tests. You can also see the power of each miner. We could visualize the exact time when miners were slashed and when they were losing power. And yeah, basically this dashboard is similar to the one at stats.filecoin.io and is very handy to developers when running tests on a test Filecoin network. So the data visualized here was extracted from one of the miners in the Testground test plan and pushed to InfluxDB, part again of the Testground platform. Additionally, all the Lotus CLI tools were also available to us when testing and running test networks with our test plan. They were incredibly useful in building intuition about the network and about the Filecoin system, while also amending configuration parameters in order to run faster tests. So we were always using scaled down block delays, proving windows, deadlines, etc. On this screenshot, you can see the table that is generating for a specific miner and which deadline they're into and what sectors they have to prove. So that's very handy if you want to understand how, let's say, missed window post proofs are handled if they're missing. So the results of this effort were that we found numerous bugs that have since been addressed in Lotus. Most of the members of the ONI team were relatively new to Filecoin, so we also improved the documentation and the specs of Filecoin in the process. In the process of writing the test kit library and the test plans, we improved the overall testability of Lotus itself. And last but not least, everyone on the ONI team learned more about the internals of Lotus than compared to what we knew prior to starting the project. As a result, a lot of the knowledge about the system was shared more broadly within the PL organization. So let's talk a bit more about where we're planning to go on from here. So Testground was used to validate performance and simulate attack scenarios for Go IPFS and GossipSub earlier this year. We used Testground to validate Go IPFS 0.5 and the performance of the new DHT improvements. And for GossipSub, we ran a number of scenarios to simulate various attacks and make sure that the network doesn't degrade when that happens. We launched the public release of Testground to the community in May, I think, shortly after GossipSub and Go IPFS were released. And from June until now, we've been testing various Falcon protocol outcomes with Lotus and Testground. So the next steps for the project are to improve the developer experience of using Testground. We want to provide a platform for developers to be able to easily schedule test runs and collect and visualize results for their own understanding and also for the community to see. This is mostly possible today, but it's rather hard and there is a learning curve involved. So developers still have to be responsible for their own infrastructure today. For example, if you want to run a Kubernetes cluster so that you can run test plans that have higher requirements for resources, you also need to know how to operate Testground. So even though all of this is documented and automated, as I mentioned, there is a learning curve and it takes valuable time away from developers. Developers are interested in writing test plans and actually verifying their own software and not running infrastructure and operating Testground. So we want to simplify this process, and we call this effort Testground as a service. So while the work on Testground as a service is in its very early stages, I want to show with you our initial MVP. So currently, it hosts outputs and test results from some of the test plans that we've implemented over the last few months as part of Project ONI. So they run on a periodic basis and confirm that we're not introducing regressions in Lotus from an end-to-end perspective. So on this dashboard, you can see that we're running the GraphSync test, the deals stress test, the deals end-to-end test, and the payment channel tests. So the outcomes column is representing an aggregate view of the different instance groups that are part of this test. For example, in the deals tests, we have a bootstrapper node and clients and miners, where clients select a random miner and initiate storage and consequently retrieval deals with that miner. So currently those tests are triggered from the ONI repository on GitHub on an hourly basis. And in the future, developers would also be able to schedule tasks on this common platform and come back later and inspect results, removing the need for them to run and operate their own infrastructure. We also continuously run benchmarks for important protocols and libraries used in Lotus, such as the Go GraphSync library, and make sure that their performance improves over time. So this dashboard provides an aggregate visualization of all the recent GraphSync test runs. So we run the GraphSync test plan with a variety of input parameters, such as the network latency, bandwidth, concurrency factor for the transfers, and size of the data to be transferred. we then visualize a data point for each test run. If an improvement or regression was to be introduced in the Go Graph Sync implementation, that would be visible here. So these dashboards are still work in progress, but this type of insight extraction is what is on the roadmap for the Testground as a service. These dashboards aim to provide an aggregate view of the performance of various protocols for the developers who are working on them, and also for the community to see. So all this is open source, and here are a few links to the test plans that we've implemented, as well to Testground itself. Use those projects and feel free to contribute back. If you have any ideas or suggestions on how to test distributed systems and provide valuable insight into them in any alternative way, something that we haven't thought about, we would love to hear from you on that as well. And last but not least, a big shout out to the ONI team, to the Lotus team, to the Spec Actors team, to the Testground team, and everyone else who contributed to the project. The findings and the validations that I've been speaking about are the result of a cross-team effort within PL, and everyone in these teams contributed immensely. So that's all from my side. Thank you for listening. Follow the Testground team on GitHub and on Twitter. And if you have any questions, feel free to reach out on the discussion forum on GitHub or on Twitter, or anywhere else that you might find us.